ideals. As we expand our horizons and look to the stars, the idea of enhancing human capabilities becomes crucial. By merging technology with our biological essence, we may not only find new homes beyond Earth, but also redefine what it means to be truly human in a universe filled with possibilities. As we gaze into the vastness of the cosmos, the prospect of studying distant exoplanets sparks the imagination. Emerging technologies are paving the way for profound advancements in our understanding of these distant worlds. One such innovation lies in the field of space telescopes. Instruments like the James Webb Space Telescope are designed to peer deeper into the universe than ever before. With their remarkable capabilities to detect faint signals from far-off planets, these telescopes can analyze light that passes through a planet's atmosphere, uncovering the chemical signatures of substances like water, methane, and oxygen, key ingredients for potential life. Another exciting frontier in exoplanet exploration is the development of advanced robotic space missions. Concepts like the interstellar probe aim to travel beyond our solar system to gather data from neighboring star systems. These robotic explorers could utilize cutting-edge propulsion systems, such as solar sails or ion drives, allowing them to cover vast distances much faster than conventional spacecraft. By sending these probes equipped with sophisticated instruments, we could gain direct insights into the atmospheres and surface conditions of exoplanets, which would dramatically enhance our understanding of their potential habitability. Artificial intelligence is also playing a crucial role in this evolving landscape. AI can sift through massive amounts of astronomical data far quicker than human researchers. By using machine learning algorithms, scientists can recognize patterns and anomalies in light curves that might indicate the presence of exoplanets or even signs of biological activity. This capability not only speeds up the discovery process, but also assists in the analysis of already known exoplanets, providing fresh perspectives on their environments. Furthermore, the concept of space elevators has emerged as another potential game-changer for exploration. A space elevator would consist of a cable tethered to a base on Earth, stretching into space. This structure could facilitate easier access to orbit, allowing for the deployment of more sophisticated instruments for studying exoplanets. While still in the realm of theoretical engineering, such a technology could revolutionize how we launch missions, making space travel more efficient and economically viable. As these technologies continue to develop, the dream of understanding distant worlds draws ever closer, turning science fiction into potential reality. Educating the public about exoplanets, those intriguing worlds beyond our solar system, requires a blend of engaging strategies. One of the most effective methods is storytelling. When scientists share their discoveries about exoplanets through narratives, it captures the imagination. By framing complex data within relatable stories, like the journey of a planet similar to Earth, audiences can connect more deeply with the information. Interactive platforms play a crucial role too. Science centers and planetariums can use immersive experiences like virtual reality and augmented reality. These technologies allow people to explore distant worlds and experience conditions on exoplanets firsthand, making the concept not just theoretical but almost tangible. Such experiences not only inform but also inspire awe, prompting further interest and inquiry. Utilizing social media is another powerful strategy. Scientists and educators can share captivating images and updates about their research in bite-sized formats. Through platforms like Twitter or Instagram, engaging visuals of exoplanet atmospheres or illustrative comparisons with our solar system can reach diverse audiences. This approach democratizes information, bridging gaps between academia and everyday life in a manner that is both accessible and compelling. Lastly, collaborating with educators to incorporate exoplanet science into school curricula is vital. By integrating lessons on space exploration and the search for extraterrestrial life in classrooms, we can foster curiosity from an early age. This foundational knowledge builds a generation more aware of our place in the universe and the significance of ongoing discoveries in the field of astronomy. Through these approaches, we can cultivate a well-informed public eager to understand the cosmos and our potential neighbors among the stars. Social media has become a powerful tool for generating excitement and awareness about scientific discoveries, including the fascinating realm of exoplanets. As we venture beyond our solar system, The ability to share findings instantly with a global audience plays a crucial role in engaging the public. Through platforms like Twitter, Instagram, and Facebook, scientists can share updates, stunning visuals, and real-time data about exoplanets, capturing the imagination of millions. One of the most effective ways to harness social media is by using compelling imagery and interactive content. For example, images of distant worlds taken by telescopes can be beautifully presented alongside engaging infographics that explain the significance of these discoveries. By inviting the audience to explore virtual simulations of exoplanets, or even participate in discussions and Q&A sessions, scientists can create a captivating dialogue that draws people in. This deeper engagement not only informs but inspires curiosity about the universe. Moreover, collaborating with influencers and creators who specialize in science communication can broaden the reach of exoplanet discoveries. When popular science communicators or educators share their excitement and insights about new exoplanet findings, they can reach audiences that traditional scientific papers might not. This helps bridge the gap between scientific communities and the general public, fostering a shared wonder about the universe beyond our own. Lastly, campaigns focused on special events, such as significant discoveries or anniversaries of landmark missions, can generate collective excitement. Hashtags, live streams, and countdowns can engage audiences and create a sense of community around these celestial revelations. By keeping the conversation alive and encouraging participation, social media can turn what might seem like distant discoveries into a shared journey of exploration, sparking enthusiasm for astronomy and understanding of our place in the cosmos. Educational institutions play a vital role in nurturing the next generation of astronomers and exoplanet researchers. They offer the foundational knowledge and skills that students need to explore the vastness of space. In schools and universities, students are introduced to core subjects like physics, mathematics, and computer science, which are essential for understanding the complexities of celestial bodies and their movements. By providing a structured environment for learning, these institutions spark curiosity and inspire students to consider careers in astronomy and related fields. Moreover, educational institutions serve as hubs for research and discovery. Many universities host observatories and research facilities that allow students and faculty to conduct hands-on experiments and observations. This practical exposure is crucial for developing skills in data analysis, telescope operation, and research methodologies. These environments foster collaboration among students and faculty, often leading to innovative discoveries that can make significant contributions to our understanding of exoplanets and other celestial phenomena. Mentorship is another critical aspect of the role that educational institutions play. Professors and researchers guide students, igniting their passion for space exploration while providing crucial insights and career advice. This mentorship can shape students' future paths, helping them navigate the complexities of academic and research opportunities. Networking within these institutions often leads to collaborations between students and professionals in the field, enhancing their learning experiences and placing them on a trajectory towards successful careers. Finally, educational institutions are pivotal in making astronomy accessible to a broader audience. Through outreach programs, public lectures, and workshops, they engage the community in conversations about space exploration and scientific discovery. By introducing young people to the wonders of the universe, educational institutions not only build the workforce of tomorrow, but also foster a culture of curiosity and appreciation for science, ensuring a continued interest in astronomy for generations to come. The study of exoplanets, those planets orbiting stars outside our solar system, has dramatically changed our understanding of where life could exist beyond Earth. For a long time, scientists reasoned that if we found other planets, they might share characteristics with Earth, making them candidates for hosting life. With advancements in technology, astronomers have discovered thousands of such worlds, broadening our perspectives significantly. This growing catalogue of exoplanets reveals an extraordinary diversity, leading us to contemplate the various conditions under which life might flourish. Many of these exoplanets orbit in what scientists call the habitable zone. This area around a star is where temperatures could allow liquid water to exist, essential for life as we know it. However, the quest for life shouldn't just hinge on finding Earth-like planets in this zone. The discovery of extremophiles, which are organisms thriving in Earth's harshest conditions, suggests that life could potentially emerge in environments vastly different from our own. This insight inspires scientists to consider a wider range of habitable conditions, including those on gas giants or icy moons, which may house subsurface oceans. The methods of studying these distant planets also enrich our understanding of atmospheres and potential biosignatures or indicators of life. By examining the light that filters through an exoplanet's atmosphere as it passes in front of its host star, researchers can discern components like oxygen or methane. The presence of these gases could point to biological processes and offers exciting possibilities for identifying signs of life in our galaxy and beyond. Ultimately, the exploration of exoplanets not only highlights the potential for life across the universe, but also invites profound questions about our own existence. As we peer into the cosmos, we are reminded that life may be commonplace, waiting for us to discover it. The continuous journey of understanding these distant worlds reignites the age-old question: are we alone in this vast universe, or are there many forms of life just waiting to be found? The answers to these queries lie among the stars, encouraging us to keep looking up. As we gaze into the cosmos, the hunt for exoplanets has revealed a stunning diversity of worlds beyond our solar system. By comparing the chemical processes that occur on these distant planets, scientists can uncover a wealth of information about their atmospheres, potential for life, and even their geological activities. This comparative analysis offers insights into how each exoplanet's unique conditions shape its chemical landscape. Each exoplanet presents its own set of environmental variables, such as temperature, pressure, and chemical composition. For example, an exoplanet that orbits close to its star may experience extreme heat, leading to the formation of different chemical compounds in its atmosphere compared to a colder, more distant planet. Analyzing these differences helps scientists understand how various factors contribute to atmospheric phenomena like cloud formation, weather patterns, and even the likelihood of hosting life. Moreover, studying volatile elements and molecules, such as water vapor, carbon dioxide, or methane, can reveal important clues about an exoplanet's history. For instance, the presence of a particular gas might suggest geological activity, such as volcanic eruptions that release gases trapped in the planet's crust. Alternatively, the absence of expected compounds could indicate harsh conditions that prevent complex chemistry from occurring, steering our search for life towards more promising candidates. By piecing together the chemical puzzle of exoplanets, researchers can refine their models of planetary formation and evolution. It's a fascinating discovery process, where each new data point not only enhances our understanding of these distant worlds, but also reflects the diverse possibilities within our own universe. The comparative analysis of exoplanets, therefore, is not just an academic exercise. It's a journey into the intricate dynamics of chemistry that shapes the very fabric of the cosmos. Exoplanets, or planets located outside our solar system, play a surprisingly significant role in our understanding of dark matter and the broader cosmos. By studying these distant worlds, scientists can gather critical information not only about planetary formation and potential habitability, but also about how celestial bodies interact with their environment. This includes their gravitational effects, which can give us insights into the unseen mass in our universe, dark matter. When an exoplanet transits its star, causing a slight dimming of the star's light, astronomers meticulously measure this phenomenon. Analyzing the light curve, the graph of brightness over time, allows researchers to infer the planet's size, orbit, and mass. This data can then be used to understand the star's mass more accurately, which in turn can extend to the galactic implications of dark matter distribution. The way these exoplanets maneuver within their star's gravitational fields informs us about the mass present in that section of space, some of which could be dark matter. Moreover, peculiarities in the motion of exoplanets can act as fingerprints of dark matter. If dark matter exists in clumps throughout the universe, some of these clumps can exert gravitational forces that subtly influence the orbits of nearby celestial bodies. By observing these gravitational interactions, astronomers can infer the presence of dark matter, piecing together its distribution and density across the cosmos. Ultimately, Measuring the subtle effects that exoplanets have on their parent stars expands our understanding of the universe and strengthens our knowledge of dark matter. As we detect more and more exoplanets with advanced telescopes and techniques, we gradually unlock the mysteries of both these distant worlds and the elusive dark matter that shapes our universe. Each discovery adds to a larger tapestry of cosmic understanding, drawing us closer to answers about the most profound questions we have about the fabric of reality. The potential discovery of life on exoplanets raises profound existential questions that touch on the very essence of our humanity. One of the most pressing inquiries involves our place in the universe. Are we alone, or is there a vast community of life forms scattered among distant stars? The realization that life exists elsewhere could fundamentally alter our understanding of life itself and what it means to be human. Additionally, the existence of extraterrestrial life forces us to reconsider the nature of intelligence. If we find life, how similar or different might it be from us? Would these beings possess consciousness, culture, or even technology? This leads us to reflect on the diversity of life's forms and the shared experiences that might connect us across the cosmos. It provokes questions about communication, understanding, and the possibility of relationships with entirely different forms of intelligence. Then, there are implications for our own existence and survival. The exploration of life beyond Earth prompts us to ask whether we are a rarity or simply one of countless life forms thriving throughout the universe. It may prompt us to consider life's resilience and adaptability, challenging our assumptions about survival in various environments, including those that might be extreme or inhospitable by Earth standards. Lastly, the discovery of life on exoplanets could invoke philosophical inquiries about ethics and responsibility. If intelligent life is found, how should we engage with it? Would we continue our explorations and attempts at contact? The realization that we share the universe with other sentient beings positions humanity within a larger ethical framework, one that could guide how we relate to one another, to other life forms, and to our own planet as stewards of all life in this vast cosmos. Philosophical perspectives play a significant role in shaping how scientists explore and interpret the findings concerning exoplanets. At the heart of scientific inquiry lies a fundamental question: what is the nature of reality? Different philosophical outlooks can lead to varying interpretations of data gathered from telescopes, space probes, and other research methods used to study planets beyond our solar system. For example, a materialist viewpoint might emphasize measurable physical phenomena while downplaying any abstract implications of findings. In contrast, a more idealist philosophy might inspire researchers to explore the potential for life or consciousness beyond Earth. This can shift the focus of research questions, from merely identifying exoplanets to investigating the conditions for life or the potential for technology to detect signals from intelligent civilizations. Another critical philosophical influence stems from our understanding of what constitutes evidence and knowledge. Epistemology, the study of knowledge, guides scientists in interpreting the data they collect. If one subscribes to a more empirical philosophy, they may favor direct observational data and reproducibility as the cornerstones of scientific progress. Others might argue that theoretical frameworks, shaped by philosophical concepts, are necessary to guide the interpretation of sparse or indirect evidence, such as that provided by transit methods or spectrographic analysis. Overall, the interplay between philosophy and science fosters a deeper inquiry into exoplanets, encouraging us to question our assumptions. The way we conceptualize life, existence, and even our own place in the universe influences the questions we ask and the significance we assign to discoveries. With each new exoplanet study, we edge closer to a broader understanding of our universe, a quest that marries the empirical rigor of science with the rich tapestry of philosophical thought. The discovery of exoplanets, those planets orbiting stars outside our solar system, has significantly transformed the way we understand our place in the universe. Traditionally, anthropocentrism, the belief that human beings are the central or most significant entities, shaped how we viewed our environment and the cosmos. Earth was seen as the pinnacle of creation, a unique bastion of life. However, as we began to uncover thousands of exoplanets, many of which exist in habitable zones, we started to realize that Earth is just one of countless worlds, possibly brimming with life and diverse ecosystems. This realization invites us to reconsider our significance in the grand scale of the universe. The sheer variety of environments found on these distant worlds, some resembling Earth closely while others flaunt extreme conditions, challenges the notion that life must be similar to what we know. The potential for life to manifest in forms and ways we had never imagined encourages humility in our assumptions and a recognition of our own limitations. Rather than being the focus of the universe, humans may merely be one possible outcome of the cosmic conditions at play. Moreover, the concept of anthropocentrism intertwines with ethical considerations regarding our treatment of the Earth and other forms of life. If we accept that life can potentially flourish in many forms across the universe, it encourages us to respect and preserve the diversity of life here on Earth. It suggests that the universe can generate life independently of human civilization, prompting a dialogue about stewardship and our responsibility to protect this planet. A broader understanding of life can foster deeper appreciation for the rich tapestry of ecosystems, presenting us as custodians rather than rulers. As we continue to discover new exoplanets, each one becomes a reminder of the vastness of the cosmos and the myriad possibilities it holds. Each distant world challenges us to think beyond the limits of our own experience. In doing so, we can foster a sense of connectedness with the universe at large, embracing a perspective that values all forms of existence rather than positioning ourselves at the center of the universe's narrative. This shift invites us into a richer relationship with the cosmos, which holds more mysteries than we can yet comprehend. Throughout history, the concept of life beyond Earth has been met with a rich tapestry of interpretations across various cultures. In some ancient societies, the stars were seen as the dwelling places of divine beings or ancestors, influencing their beliefs about the cosmos. For example, in many indigenous cultures, celestial bodies are often linked to creation stories, and life beyond Earth is intrinsically woven into their spiritual frameworks. These perspectives can foster a sense of connection to the universe, prompting questions about humanity's place within it. Conversely, many Western cultures, particularly during the Enlightenment, began to approach the cosmos through a scientific lens. The idea of extraterrestrial life shifted from myth to an inquiry grounded in observation and reason. Notably, the works of philosophers and scientists like Giordano Bruno and Carl Sagan invited people to consider the universe as a vast expanse potentially brimming with life. This historical shift not only ignited scientific curiosity, but also propelled advancements in technology and exploration, leading to missions aimed at discovering signs of life beyond our planet. Cultural beliefs also directly impact the way scientific inquiry is conducted. For instance, societies that view Earth as unique may prioritize finding life on Mars or within our solar system. In contrast, cultures that embrace the notion of life existing elsewhere without restrictions may support broader searches for exoplanets capable of supporting life. These differing perspectives can shape funding for research and the types of experiments scientists undertake, as well as influence public interest in space exploration. Ultimately, as diverse cultures continue to share their interpretations of life in the universe, they enrich the scientific discourse. The collaborative interactions between cultural beliefs and scientific exploration enhance our collective quest to understand not just our place in the cosmos, but the possibilities of other life forms existing among the stars. This ongoing dialogue between humanity's cultural narratives and scientific endeavors keeps the curiosity alive, inviting each generation to reflect on what it means to be human in a universe that may not be as empty as we once thought. International cooperation in exoplanet research opens the door to a wealth of exciting possibilities and advances in our understanding of planets beyond our solar system. By pooling resources, knowledge, and expertise from various countries, scientists can undertake more ambitious projects that no single nation could manage alone. This collaboration helps to share the financial burden while allowing researchers access to advanced technologies and instrumentation that enhance our capacity to detect and analyze distant worlds. Moreover, teamwork across borders fosters a diversity of ideas and perspectives. Different approaches in science can lead to innovative techniques for discovering and studying exoplanets. For instance, A satellite designed in one country could work synergistically with ground-based telescopes in another, leading to more comprehensive observations. This kind of collaboration not only accelerates progress, but also enriches the scientific dialogue, allowing researchers to learn from each other's experiences and methodologies. Additionally, sharing data on exoplanet discoveries creates a more thorough and robust understanding of these celestial bodies. When scientists from different countries contribute to a common database, they enable a richer analysis and a higher chance of significant breakthroughs. This inclusive approach leads to improved understanding of potential planetary habitability and the myriad factors that contribute to a planet's atmosphere and conditions. Finally, international cooperation can inspire public interest and investment in science. Collaborative missions project a united front, which can capture the imaginations of people worldwide while promoting education and engagement in the sciences. When researchers from various nations unveil findings together, it showcases a collective human effort to explore the universe, fostering a sense of shared purpose that benefits all of humanity. This journey beyond our planet is not just an exploration of the cosmos, but a testament to what we can achieve when we work together. The study of exoplanets, those distant worlds orbiting stars beyond our own solar system, opens fascinating windows into the dynamics of planetary bodies, including our Earth. By examining the various atmospheres, geological features, and potential climates of these exoplanets, scientists can glean critical insights into the processes that shape all planets, including our own. This comparative approach allows for a deeper understanding of the Earth's unique characteristics and the challenges we face today. For instance, by studying exoplanets that exhibit extreme greenhouse effects, researchers can better grasp the impacts of climate change on Earth. Some exoplanets have thick atmospheres that trap heat, creating uninhabitable conditions. Observing these worlds lends perspective to our own atmosphere's delicate balance and highlights the importance of greenhouse gas concentrations and their long-term effects on climate. In turn, this knowledge can inform our responses to global warming and ecological challenges here at home. Moreover, the geological activities of other planets provide a broader context for understanding Earth's tectonic processes. Many exoplanets exhibit volcanic activity or unique surface formations that serve as analogues to Earth's geology. Studying these phenomena helps scientists unravel mysteries about plate tectonics, the formation of mountains, and the evolution of planetary surfaces. This cross-comparison can help sharpen our focus on natural disasters such as earthquakes and volcanic eruptions, making Earth's processes clearer in the grander cosmic picture. In addition, the search for life beyond our planet hinges on understanding conditions that might foster habitability. By examining which exoplanets lie in the so-called Goldilocks zone, where conditions are just right for liquid water, scientists enhance their comprehension of what makes Earth a unique oasis in the vastness of space. This quest not only enriches our knowledge of planetary formation and evolution, but also guides efforts in protecting and preserving our own planet's delicate ecosystems amidst growing environmental pressures. As we venture deeper into the study of exoplanets, several captivating themes and discoveries are poised to shape our understanding of the cosmos. Firstly, the search for potentially habitable worlds is at the forefront of exoplanet research. Scientists are not merely cataloguing newly discovered planets, but are delving into their atmospheres and chemical compositions to seek out the conditions that might support life. Instruments like the James Webb Space Telescope will play a crucial role in this effort, allowing us to analyze the atmospheres of these distant worlds for signs of water vapor, methane, and other vital indicators. Another significant theme emerging from exoplanet research is the diversity of planetary systems. Our solar system, with its relatively uniform arrangement of rocky and gas planets, is just one of many possibilities. Astronomers have discovered systems featuring not only gas giants orbiting close to their stars, but also unlikely arrangements such as super-Earths and mini-Neptunes. Each discovery adds to a growing catalogue of the variety of planets and orbits that exist throughout the universe, prompting scientists to rethink the dynamics of planet formation and migration. As technology continues to advance, researchers will also explore the atmospheres of exoplanets in unprecedented detail. Future missions aim to identify chemical biosignatures, which are indicators that life, as we know it, might exist or have existed on these planets. The ability to detect complex organic molecules and analyze light spectra from distant worlds may provide insights into evolutionary processes and the potential for alternative life forms. Lastly, the exploration of exoplanets invites us to confront profound philosophical questions about our place in the universe. As we uncover more about these distant worlds, we grapple with the implications of finding life beyond Earth. The realization that we might not be alone could reshape our understanding of life itself, pushing us to expand our definitions of habitability and intelligence. Each discovery not only adds a new chapter to our scientific knowledge, but also deepens our connection to the universe, reminding us of the wonders that lie beyond our home planet. The documentary format serves as a powerful tool in enhancing public understanding and appreciation of the complexities of exoplanets. By blending stunning visuals with engaging narratives, documentaries can bring to life the vast and mysterious worlds that exist beyond our own solar system. This visual storytelling captures the imagination, allowing audiences to see what exoplanets might look like, how they are discovered, and the various conditions that make them unique. When viewers can visualize distant planets and their potential for habitability, it ignites a sense of wonder about the universe. Moreover, documentaries can simplify complex concepts related to exoplanets through expert interviews and accessible explanations. Speaking directly to scientists and astronomers,